Okay. Hi guys. Yes, walaikum salam. Alhamdulillah. Good. Mm, yeah. Majority of you are asking about this one regarding what you call your second term exam is coming. So I hope majority of the schools, certain schools are up and down, there are fluctuations. But in terms of majority of the schools that are having your second term exam on 31st, if I'm not wrong. So 31st is a Thursday and on 30th is Wednesday. So on 30th, I'll be actually doing a free seminar for you all. It'll happen only online. And it'll be targeting your terms test. So I'll share those details in the Master ID WhatsApp channel. So if there's anyone out there who is not in the channel, just make sure that you're there in the channel so that you get those details. I'll just share the channel link as well. Okay, give me a moment. Copy, paste. Yeah. So I send the link of the channel in the chat. So just have a what do you call make sure all of you are there in the channel so that when I upload those details, we get it on time. Anyways, what do you called? I'll give you all 10 minutes. Start for some of the physical class students. I would have given this paper already. Some of the physical class did not get. Most of the physical class students got. So in the last week class, I would have given one like an A4 shoot. I didn't still give the paper class to it properly because the files are still on process. Actually, I can show you the file design. No, I'll show it later. First, I'll do this question. Give you 10 minutes. Let me on the timer first. Um, apps. Okay, I have on the timer for 10 minutes. Start doing the second question. It's a continuation of the same paper. Paper class 2 has not still been dispatched. Because again, the file is still on process. But the physical classroom would have got it. Just that this paper only, not all the papers. Like I can show the rough sketch of the design. Actually, design because the design only got delayed. Like this is how your paper class file is going to be. Let me just remove this object. We are still working on this, but yeah. So once this is the today I complete the back page of the back page back cover. So what do you call once it's printed, you'll be getting it. So just as soon as possible, I'll make sure it's there for you. Sorry on the delay. Yeah, that's fine, Michelle. Thank you. Thank you. Yes, start the question, Alpha. Those are done with answering this question, raise your hands up in Zoom, okay? We'll have 2 minutes remaining. Thank you. All of you will do this question. Once you're done, raise your hands up in Zoom. If there's any questions, drop in the chat now. Yeah, I was on time. I think I was only for the physical class, then physical class, then physical class. Because I have asked the paper class is supposed to maintain a separate writing book, and I'll be screen sharing the question. You can see the questions and you can answer. You'll be getting the printed versions of this once the file is ready. The tweet conventions and filings in the back cover. Yes. Wait and see. Thank you. Agnish, I have sent the recording in the WhatsApp community. Let's check there. So last week I gave in the classroom. Did you get it? Then a paper I gave you on the end of the class. Two papers. One of that is this. Okay. So the second question is the question I gave you all do now. Let's check your answers. By the way, those who joined late, what you called the beginning of the class I mentioned, I'll again repeat it again. On majority of your schools are having the second term test on 31st. which is a Thursday. So because of that, I'm planning to do a covering some part two question discussion regarding 11 for the second, discussing a second term test paper. The day before that, it's on 30th, it's on Wednesday night. Online only, it will happen. And the details of that I'll be posting in the WhatsApp channel. So if you're not there in the Master IT WhatsApp channel, the yellow color logo one, click on the link I sent in the chat and join the channel. Okay. Let me just have the writing book ready as well. So if there's anything to write, we can. Yeah, that's fine. Okay. The question says an operating system is a system software, and it is very important to the operation of the computer. Okay. Write two examples of the system software rather than it should be apart from the operating system. Okay, perfect. I think I discussed something relevant similar to this in a couple of weeks back. What do you call paper class as well? But I'll just repeat. So if you take the software, I might have the sketch already. We did a couple of weeks back, so I'll directly go for that. Didn't, 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 didn't. Didn't I do a question regarding that? I remember doing it very recently. Okay, maybe for grade 10, I did not figure out. Oh, no, can't be grade 10. Grade 10 I have not done it. Okay, I'll do it again. This is a theory unit, right? Yes, correct. This is our job. Tudum, tudum, tudum. Here. What do you call? Couple of weeks back, we discussed a question similar to this. And I told you that there are two types of software. One is a system software, and other one is the application software, right? So if you look at this question, the question is saying they're asking for two examples of system software apart from the operating system. So now when you take system software, you can categorize system software into three categories. One category is the operating system. The other category is something called as utility software, and the other category is something called as language translators, right? So in general, if I'm going to first of all itself compare, what do you mean by a software? First of all, software is basically a program or else an application that you have in a computer, you can call a software. Like in your phone, you have this what you call WhatsApp, Viber, Instagram. These are different programs or different apps, right? These are what we call as softwares, right? So we can categorize the softwares main in two categories as system software and application software. And in the big picture, the main difference between system software and application software is system software are the types of programs that is like compulsory. You need programs to use the device. Like for example, in your phone, if you don't have the settings application, you'll not be able to use your phone properly. Because for example, you can connect to a Wi-Fi network, you can connect to a Bluetooth network, you can on the phone's hotspot. Like the main functions in your phone you can do if your settings application is there. Imagine they remove that settings application. And if they remove that settings application in your phone, you can't do lots of stuffs, right? So that's like important software, right? So the software that are or the programs or the apps you need in your device compulsory. Without that, you can't use the device properly. Those are like system software. Application software are the programs we separately go and download or install to make our work easy. Or like for example, when you buy the phone itself, WhatsApp will not come, Viber will not come, Facebook will not come, Instagram. These are not applications that will come with the phone. If you want that app, you go and install it from the let's say Play Store, App Store, Microsoft Store. From the internet, you can go and download that apps and you can start using. So when you're downloading it mainly for a purpose. Like for example, you might download WhatsApp to send messages. You might download YouTube to watch videos. But if you uninstall those two apps also, still you can use the phone, right? So the phone apps you download to make your work easy or to get some extra task done, those are the application software. So there are two main categories. And in this system software, which means out of these compulsory softwares, we can classify them into three categories. One is operating system, utility software, and language translator. Now, at the end of the day, if you take your computer or your phone or your laptop, this device is created or this device is developed by a combination of several hardwares. What I mean by hardware is certain tangible components, the things you can touch and feel and see. Like, for example, in your phone, in your laptop, the speaker is one hardware component. Your display is a hardware component. Then, for example, if you take your laptops, the keyboard is a hardware component. Or else, for example, it's your display, speaker, microphone, these camera, these all different hardware components, hardware devices, right? So by default, if you want to interact with them, now, for example, let's say you want to play a music, okay? You go to YouTube, and once you go and click on this video, so there's a video, you go and click on this video in YouTube, you want the sound of this video to be played through your speaker. You want the sound of this to be played in your speaker. So now you have the YouTube application and you have your speaker in your computer. There should be a way of how your YouTube application can tell the speaker, hey, speaker, play this song, right? So to facilitate that communication, to take that request from this application and to go and give it to the hardware, to communicate between these two, to communicate between other softwares and hardwares, or to make you be able to interact with your hardware, for you to be able to control your hardware, for you to give instructions to your hardware, to get the use of the hardware only, we have this type of system software called as operating system. So one of the main key purpose of the operating system is basically to interact with your hardware, for you to be able to control your hardware, for you to be able to tell your hardware, hey device, do this killer. Okay. So for you to be able to interact with those, you have the operating system. So if you're using mobile phones, majority of you might be using either Android operating system. If it's like Samsung, Huawei, those no Redmi or Xiaomi, all these phones follows the Android operating system. Or if you have an Apple phone, then you might be using iOS operating system. These are two main operating systems for mobile phones. There are more, but these are the two main. If you're using laptops and computers, majority of you might be using a Windows operating system. Apart from that, if you're using an Apple or a MacBook, basically, you might have something called as Mac operating system. Okay. So these are like the top 4 operating systems used in for like our day-to-day purpose. But apart from that, there are operating systems like Linux, Unix, Killer. There are more other operating systems as well. So these are operating systems that allows you as a user to be able to give instructions to your hardware or facilitate the instructions between a software and hardware in simple words, right? Then utility software, these are like the softwares we have in our, what do you call, phone, or I mean in our device. Okay, these are software we have in a device that will make our work, make us be able to do certain functions using our device. Like for example, if you take your settings application, inside your settings application, there are several components. One of that component, or one of like components, I'm saying functions. Inside like using your settings app, you can do several stuffs, right? One of the stuffs you can do is you can connect to your Wi-Fi. So ability to connect to Wi-Fi, that's one program. Even though it's coming inside your what you call settings application, that function is actually a separate program. Okay. The ability for you to connect to a Bluetooth, that's a different program. Then ability for you to go and check what are the apps you have in your device, the app management. Okay, you can go and see the amount of storage taken by each app. Those are different apps. Or let's keep those things aside. Now, for example, if you're using laptops, you might notice in laptop, if you have a Windows laptop, you all know this Windows key, right? The key that looks like this, and it has a, what do you call the Windows key? The key that looks like this, to be precise. Let me off the blur. Yeah, this key. Okay, this is the Windows key. Next to the, like, this is a space bar. So Alt and the Windows key. Right? When you press this Windows key and the letter V, this Windows key and the letter V. If you press both of them together, you'll be getting something called as clipboard. I don't know how many of you all know about that, but if you have a laptop, you can try. So once you go and press this clipboard, I can show it to you if you want. Let me just go full screen sharing. So if I go and press the Windows key and V key together, you can see in my clipboard, it's showing me what are things I have stored. So it's like all the things I've copied. See, all the things I've copied are there here. What do you call there? So all the things I copied means, like, for example, let's say I copy a word now, and before that another word, and before that I had copied another word. In all these 3 words, I can go and see in this clipboard. So this thing called clipboard, this thing you can see in the pop-up, right? This is called a clipboard. Now this is a type of utility software, right? So in your computer, you have these small softwares that makes your work more easy or may give you a type of purpose, right? Windows key and the letter V. Windows plus V. The letter V in your keyboard. If you press this, you will get the clipboard. Okay. So likewise, in your computer, there are these small applications that are there and that will make your work easy. Okay. So what do you call? Oh, no, I'll come to that in a while, right? Okay. So likewise, in your phone, like if you take certain applications, are there certain things are there. If you have used these ones, if you are users of what do you call Apple devices, then you might notice in Apple there's an application called Notes, right? Okay. Now, when you type a note in your phone, let's say you have iPhone, in your iPhone, you go and type there's an app called Note app. In that Note app, if you go and type, what do you call a note? Let's say just go and type some text and keep, right? You can go and open this Notes app in your laptop as well. Even in Windows laptop also you can, even in Mac also you can. Let's say I go and open that same Note app. If I go and open that same Note app, that same thing I typed in my phone is there, right? I'll be able to see it through my laptop as well. Because these are all synced. Okay, the word synced means it's like connected or updated. So if I go and type something in the notes app using my phone, even if I go and access the same note using my laptop, still it will be updated, right? So likewise, if you take one operating system, they have those kind of what you call syncing software as well that runs in the background. Like syncing means updating automatically. When you do a small change, it updates, right? Now, for example, even this PDF I'm writing here, okay, when I go and click on save here, okay, in the right setup, I can go and click on save, right? So once I go and save this document, right? Once I go and save this document, after like behind the scenes, what will happen is without my knowledge, right? It will be uploading or it will be updating this in what you call my Google Drive. So if you all notice in the WhatsApp community, after the paper class over, I might share you all, okay, these are recording of the class, these are filled PDF, the unfilled PDF, right? If you go and click on that filled PDF, that link, you might see whatever I write here will be updated, right? I don't go and change the link every day. If you go and see every day the same link, or it's there for the PDF, right? So it gets auto updated. Whatever I go and save, it will get auto updated. So this is also done by one of the utility softwares. So in your computer, in your device, there are these small programs, essential programs that we might not sometimes directly what do you call it, connect with it, but it has different purposes. Okay, so there are several utility programs as well. I'm not going to tell all the examples, but the point is those are like essential programs in your device that are there and that will make your work easy, right? But the email has to be same for the sync now. You did not understand what you mean by sync yet. You mean it shows a clipboard panel history? Yes, it shows all the histories of whatever you have copied. Okay. So what do you call the point is apart from utility software, this file is there. This file is not a file in my laptop. You can is it like if you can see in the top itself. This is not a file in my laptop. It's a file in my G/my drive. This is the first time. Okay, I'm not going to explain about that. That's irrelevant data at the moment. But this file is not stored in my computer. Even though I'm opening it through my computer, this file is not a file stored in my PC. It's a file stored in my Google Drive account. Anyways, keeping that thing aside, what do you call? So the point is, in your computer or in your phone or in your laptop, there are certain softwares that are available, which are compulsory, which will be there by default. You don't have to install it. By default, it will be there. And it performs certain small functions to make your work easy, right? It's like pre-installed apps, kind of pre-installed apps that has a dedicated purpose, obviously. Yes, correct. Okay. You can see it through your lap because they're same username. What do you mean? And the third is something called as language translators. Language translators also are certain types of softwares or it's a program that's again compulsory there in your device. And the purpose of this is you all know by default, if you take your computers, by default, computers or else your hardwares can understand only one language. What is that language? The hardware components in your computer, it can understand only one language. What is that language? Correct. Yes, exactly. Actually, binary is not a language. Binary is actually certain types of symbols in the big picture. So the name of that language which uses binaries only. There is a computer language written with the use of binaries only. That language we call as a machine language. So machine language is a language that's written, language that has only binaries used. Okay. So by default, if you take your computer can understand only one language called as a machine language. Machine language contains binary numbers. Huh? So, like for example, if I take English language contains alphabets from A to Z, which means it has letters from A to Z, right? But machine language has, if you take the alphabets of machine language, it has just ones and zeros. That's the like idea. Okay. So, what do you call if you take this machine language? By default, when we are creating big programs nowadays, we don't write programs nowadays in machine language. Mostly nowadays, we write programs in a type of language called as high-level programs, high-level programming languages. We use a type of programming language called high-level programming language. This is a type of language that is almost similar to English. Like all the words in this language, all the words in this language are English. You can have different languages as well, but majority is English, right? So because it's in all in simple English words, it's very easy for a programmer or it's very easy for a developer to write these programs. So what we do is we write a high-level program. We write the programs in high-level language, and then Pascal is an example of high-level programming language. PHP is an example of high-level programming language. Then what you called Python is an example of high-level programming language. These are all examples for high-level programming languages. Okay. So what happens is we write the program in high-level programming language, and when the program is running, when you go and open the application, what happens is this program is actually converted from high level language. It is not converted, it's translated. It is translated from high level language to machine language. Because at the end of the day, if you want the computer to understand your program, the program has to be in what? Machine language, right? If you want if you want the computer to understand your language, it has to be in machine language. So therefore, to convert this from high level language to machine language, we have certain language translators. Not only high level, there are certain other types of language as well. In the first lesson, we learned there are three types of languages. So there are two types of language, low level and high level. Under low level only, machine language and assembly comes as example. So apart from machine language, any other language you write a program, it has to be converted to machine language. And to convert to machine language, we have this, what do you call, language translators. So some of the examples for language translators are, we have something called assembler, we have something called compiler, and we have something called as interpreter. Okay. HTML is not a programming language. Java is not a type of programming language. It's an example of programming language. I said there are two main types, low level and high level. Under low level, there are two examples, machine and assembly. Under high level, there are tons of examples. Right? Okay. So what do you call in the big picture? Again, I'm telling you, when you take the softwares, all these system softwares, whether it's operating system, utility software, language translator, these are all softwares you don't have to install separately. When you buy your computer, when you buy your device itself, all these softwares are already there. So in this question, they are asking you two examples of system software. So if you want, you can mention the type of system software, which means you can mention the answer here as what do you call utility software as one example. And you can mention language translators as another example. You can mention the type of softwares as the answer here. Or else, without mentioning the type of answer, if you want, you can also mention examples. Meaning, if you want, you can mention, without mentioning utility software, you can mention disk backup software, or you can mention disk partitioning software, or you can mention any other stuffs as well. So without mentioning language translators, you can go and mention examples, like for example, assembler, compiler, interpreter. If you want, you can mention examples of language translators as well. My recommendation is mention the types of softwares, but because they have directly asked you examples of system software. But if you want, you can mention example of utility or example of language as well. Both are correct. Dollar mark is put in, not in, only in what do you call PHP. That's not relevant here. What's below compiler? What's this backup software comes on? This backup comes under utility software. BIOS is not an example for what do you call system software. BIOS is not BIOS is not a software itself. First of all, BIOS, even though we call BIOS as a program, BIOS is a program, not a software. Okay. So a type, what do you call? If you take all these softwares, for any of these softwares to be used, you need the operating system. Without the operating system, you can't use a software. There is a different type of program called firmware. Firmware is also like a software. The difference between firmware and software is firmware is a program. Or imagine when I just say the word program, keep in mind, program means app. Okay, like imagine an app, right? A software, an application. So if a program can run with, if for a program to run, if you need the operating system, then that's going to be a software. But for a program to run, you don't need the operating system. Like without the operating system, also you can run the program. Those are called firmware. So BIOS is an example for firmware. We don't need operating system to use a BIOS. Without operating system, also you can use BIOS. So BIOS is not an example of software. It's actually a firmware. So if you wrote BIOS, the answer is wrong. Command prompt. That's an application software. So the answer is wrong. If we need the operating system for software, then why is operating system under system software again? That's a type of software. So that's fine. Then did you say or keep the test for okay, 11 question? Okay. If you have any questions regarding that, drop in the chat. Huh? Do we need an operating system to run command prompt? Without a command prompt, how can you run an operating system? CMD is actually an application. Command prompt is an application you have in your device, right? Then it's an app, right? So without the operating system, how are you going to open that? If you don't have Windows, can you open? Now, if you take BIOS, even if you don't have Windows in your device, you can open the BIOS. If you all know, on in the on in the computer, have you seen after the logo in the bottom it will show press F12 to continue BIOS or something killer. Like on in the computer, just press F12. Most of the computers is F12, but certain computers the key numbers can vary. Like if you look at the computers in the top picture, you have this function keys F1, F2, F3. As long press F12 again and again and again, we'll be getting something called as a BIOS. It's a program that can run without an operating system. Okay. What do you call it if it's an operating system? Is what do you call it if an operating system is needed for the software? Software. In general, if you take the word software, the word software is referring to interact. Software is basically something that you can use to interact with your computer. Because by default, your computer is there. Your computer is a piece of hardware. What I mean by piece of hardware means a computer is composed by a collection of things that you can touch and feel and see. Your speaker is a hardware, your microphone is a hardware, your camera is a hardware, your what do you call keyboard is a hardware, monitor is a hardware. These are all hardware components. By default, you can't talk with the computer now. Like for example, if there's nothing, if there's no any way you can speak, if there is no any ways you can talk with the speaker. If it is just hold that hardware component, we talk with that hardware component, look at the speaker and then, hey speaker, play the, no, these are hardware. This is a hardware component. This is a hard disk actually. Okay. But if I go and tell this hardware, hey, hard disk, please store my name. Will it be able to store the name? No, because why? This is just a hardware component. So if I want to store some names in this, I had to create a software. And through that software, only I have to feed the data to this. Okay. Like I have to create an application where through that application, I can put data inside this. So software is basically a type of program that you can use to control your hardware or to give instructions to your hardware. Make sense? The difference between firmware and software. Firmware and software, if you ask me the similarities, both of them are programs. Program means they both of them are apps. And if you ask me the difference, for a software to use, for you to be able to use a software, you need an operating system. For you to use a firmware, you don't need an operating system. That's the difference. Got it? A hard disk usually that's more. I have smaller than that hard disk as well. That's a bigger hard disk. What will be the examples for firmware? BIOS. BIOS syllabus only BIOS. I wrote computer-based system and memory system. That's the two types of systems, man. Not relevant to this. Okay, so firmware is a type of program that can function without an operating system. Next, what are the two types of file accessing methods of the operating system? Okay, now when you take your computers, obviously in your computer you might store certain files, right? Files and folders and all those stuffs might be there. So for example, let's say I have a folder, and let's say I have a folder called what do you call classes. Okay, and let's say inside this classes folder, I have another folder called grade 11, and let's say I have another folder called grade 10. Yes, Umar, it's there. Okay, let's say I have two folders. One folder is called grade 11, and let's say another folder called grade 11. And let's say inside this grade 11 folder, I have for every tute, I have one separate folder. For example, let's say lesson 1 kill, I have one folder. Lesson 2 kill, I have another folder. Lesson 3 kill, let's say I have another folder. So for, let's say for every lesson, I'm going to have one folders. And inside the lesson 1 folder, let's say I have the PDF of the tute. And let's say I have the Word document of the tute. Now, docx means the Word document. PDF is the PDF document. Okay. Now, if I want to open this tute's PDF version, what I might do? First of all, I'll go and open the classes folder. Okay. Then after I open the classes folder, I might open the grade 11 folder. Like that, I might open. For example, if I show you all here, let me just open my computer. The usual process might be, let's say I might go and open one folder. Inside that, I might go and open another folder. Then I might go and open another folder. Let's say I go and open ICT classes. I go and open grade 11. I go and open what do you call it, say, internet and email. And I can go and open the PDF, let's say. So if you notice, to access this file called what do you call internet and email, I went step by step. One folder, another folder, another folder, another folder. Now let's say I want to go and access the grade 10 folder. So I might go one step up, one step up. Again, now I might go to grade 10. Then I might go to open the grade 10's folder. So if you notice here, the way I'm accessing this file is from the classes folder, I'm going to go for the grade 11 folder. From grade 11, I'm going to go to L1. From L1, I'm going to PDF. And when I want to go to grade 10, from grade 10, I'm again from PDF, from this file, I'm again coming for the L1 folder. And again going for the grade 11 folder. I'm again coming for the classes folder. After I come for the class folder, from here only again, I'm going to go for the grade 10. Like for example, notice here, if there's multiple folders, I'm going one after the other, from here to here, here to here, here to here. And if I want to come back as well, I'm going to come folder by folder, I'm coming back. So if you're going to access a file like this, we call this as sequential access. Step by step, you're going to access a file. There's another way of accessing files as well. Like for example, if you look at my computer, let's say I want to access the paper class tute. To access the paper class tute, I'm not going to go one by one from folder by folder. In the left side, you can see shortcuts there, right? So I'm going to go and click on this free paper class, and all my paper class tutes there. Now, directly I came to this folder. Okay, now let's say I want to go for the, what do you call, my main drive. I go and click on this my drive part. So it'll take for my main drive. Okay. So if you notice here, I'm not going to go folder by folder and open like this. Instead, randomly, I'm going to jump from one folder to another folder, one folder to another folder. So without going step by step, you're going to randomly go from one folder. Let's say you have multiple folders like this. Without going from folder 1 to folder 2 and then 3 and then 4, if I directly can go to folder 4. And from folder 4, if I can directly go to folder 2. Like this, randomly, if I can jump folders, this is what we call as random access. So in accessing files, there are two types of file accessing method. One is the random access. That's the second one I showed you. And the first one I showed you was a sequential access. These are the two types of file accessing method. So if they give you a picture like something like, let's say, if they give you a picture like this, where they now here put boxes, no? Instead of boxes, they'll call this folders. So if they're given a picture like this, then if they ask you, okay, and if they have put the arrowheads like this, from folder 1 to folder 4, folder 4 to folder 2, like this, randomly, if you can access the folders, it's random access. But to access a file, if you have to go step by step, so 1 to 2, and then 2 to 3, 3 to 4, and if you're going to come back 4 to 3, 3 to 2, 2 to 1, step by step, that's called sequential access. So these are the two types of file accessing method. Is that clear enough? Anyone have any questions there? I wrote direct access and sequential access. No, you have put sequential access and random access. Okay, if there's any questions, drop in the chat. Huh? So again, how your marks are going to be is for utility software, 1 mark, language translation 1 mark, random access 1 mark, sequential access 1 mark. Next, what are the four components of a graphical user interface? Okay, I told you a while ago, for you to interact with the computer, for you to be able to control the hardware, we have something called as operating system. So if you take this operating system, this the program known as operating system, this can be present in two forms. One of the form is where the operating system is going to be in a program that contains just completely a black and white, what do you call visuals. In terms of what you can see, let's say it contains just a black and white textual elements only. Just only text. There is on text means it can be a number, it can be letter, it can be symbols, but it's just only white, black and white character. There is no emojis, there is no what do you call pictures. Okay. So if you're going to have what do you call a program like an interface that's going to contain just only black and white stuffs, we call that type of operating system as a command line interface, CLI. Okay, command line interface. So in command line interface, it's like a program where you can control your computer, but again, everything is going to be black and white and only characters, right? So for example, if I take my computer at the moment, in my computer, I have this command line interface as a separate application, but there are certain types of operating system. When you're on the computer itself, you can see just only this thing. You all currently you can see I have this as a separate window. No, this is called a window. I can move this here and there. So this thing is called a window. Then I have another window like this. So for example, take my file manager. See, I can move this application here and there, right? So this is called another window. So this is one window and this is another window. Okay. So I can see this as a separate window, right? But if you take what do you call the certain command line interface, when you open the laptop itself, when you open the computer itself, you can see only this. So this is called the command line interface, right? So here I can interact with my computer using certain codes. Like for example, if I go and type a ls, it will show all the files in that folder. So to open a folder, I can type here certain codes. So if I go and write CD downloads, it's opening my downloads folder. So if I say ls, it's going to show all the files I have in that folder. So you can see here, what do you call? See, it's still showing me all the files. You can see everything is technically black and white, completely black and white only, right? So those types of interface we call as a command line interface. But apart from that, the interface which we use now, for example, you can see my laptop at the moment, or else your laptop, your phones, your computers. So nowadays, the operating system you all have that comes under category called as graphical user interface. Correct. Okay, that comes under something called as GUI, which stands for graphical user interface. So if you can see colors, if you can see what do you call images, all those stuffs, that interface is basically a graphical user interface. So if you take Windows, iOS, Android, Mac, these are all what do you call graphical user interface. Okay. Yes, these are two types of operating system. One is graphical user interface and one is a command line interface. So in this question, they were asking in the graphical user interface, what are the things you have? What are the main components? So graphical user interface has four main components. The shortcut method to remember them is Vim, where W stands for what? The graphical user interface has four components. We're learning the grade 10 lesson number 5, right? Called Vim. What does W stand for? I told a while ago, actually. Perfect. W stands for window. Okay. So you have window. What does I stand for? Perfect. Why? Yes, I stands for icon. And then icon means you can see in my app, like laptop, if you take at the moment. If you look at my home screen, you can see what do you call for every fold I have a different picture I can use to see it, right? So these are icons. So rice recycle bin has a picture, this piece has a picture, every fold has a picture. So they are called icons, right? And then what does M stand for? Correct. M stands for something called as menus. Like for example, if you take your laptops, when you right click on something, you get options. Like, for example, I right click here, you can say option. When I right click on my laptop, I have something called add text, forward, refresh, save, print. This is called a menu bar. Like if I right click here, I'll get different menus. See? Or if I right click on my home screen, I might have a different menu. So these are called menus. So when I go right click somewhere mostly, you'll be able to have this something called as a menu that can hover up or that can come on top, right? So this is the third type of thing graphical user interface will have, this thing called menus. And finally, what does P stand for? Perfect. P stands for pointer. So pointer is basically you can see my mouse, okay, or if, at the moment you can see like a pencil moving here and there, but you can see now my mouse pointer, okay, that which has something like this, which looks something like this. And using this, I can select exactly where to go and click. Now, for example, if I want to go and click on the first tab, in my browser, I have three tabs open. If I want to exactly go and click on the first tab, I can take my pointer towards the first tab and click on it. So it will correctly go and open that tab. If I want to open the third tab, I can go and click on the third tab. If I want to go and click on this erase icon, I can take my mouse pointer towards the erase icon and click on it. So using the pointer, you are able to select exactly what you want. So these are the four main components in a graphical user interface. Anyone have any questions here? If there is any questions, drop the chat. Huh? So here the answer has to be, the four components has to be Windows, comma, icons. You can always keep in your mind the Vim part. Windows, icons, menus, and pointers. So window icon, menu, pointer. If you had mentioned these four, put half marks each for every answer. Singular plural is not a problem. We never learned anything about this at school. It's actually there in the fifth lesson, grade 10. Can't we write cursor? No. Because for example, what you can see at the moment is like the triangle icon is there. Right? This is what you call as a cursor. If you take your phones, in your phones, can you see this cursor? By default, there is way you can make your phone get this cursor. But by default, in your phone, do you have this cursor? No, right? In your phone, how do you point at stuffs using a finger? So in your phone, there is no direct visible cursor. Wherever your hand goes and touches the display, it goes and clicks that place, right? So in your phone, the pointer is actually something that's invisible, right? Now, for example, when I'm writing here as well, can you all see any now? At the moment, when I'm writing here, can you see like a small circle close to my where this letter A is? This is also a pointer. So this point you don't call it a cursor. This is a pointer. So there is different types of cursors. So there is different types of pointers. Cursor is in a type of pointer. So this a cursor is basically an example for a type of pointer. Got it? Pointer is our finger, not exactly. Our finger is an example for a pointer. The cursor is an example for a pointer. We haven't heard about it. We haven't completed the grade 10. Oh, you have not completed the grade 10 syllabus? That's sad. Anyways, got the idea? Rough idea? If you don't see those pointers if you notice here, this is what cursor is. Okay, to be the exact meaning of cursor, this is what cursor is. Can you see in this, what do you call, in this command line interface, can you see something is blinking in the bottom? That's what actually cursor is. This is the correct, you can call this, the mouse cursor also cursor, like the mouse, the triangle thing also can got cursor, but the exact word of cursor is what you see here. This fellow is there. Let me make it red color. This is what you call as a cursor. Cursor. Like if you have opened a Microsoft Word document also, Typing, you might have that blinking, right? So that's what cursor is. So you cursor is mainly a part in cursor is a main component in a command line interface, not a graphical user interface. Got it? That I letter, yes, the blinking. That's what a cursor is. Yes, Hannah. There are certain questions you'll come across, then you can know how to answer. Then these all make the meaning WIMP. Yes, exactly. So WIMP is Windows icon minus pointer. It's a short form to remember these four words technically. If there's any other questions, drop in the chat. I'm going for the next one. A file consists of both a file name and a file extension. What is the importance of file extension? Okay. Now, when you're opening certain files, you might see at the behind of the file, you might have something called file extension. Like this. For example, if I open my files, downloads folder, let me go. If I go to my downloads folder, I all can't see the full screen share, right? Yes, Hannah, you have to. I actually thought one day as I can remember. If there's a question really relevant, I'll teach again. If you look at my what do you call files, here I have different types of files. The first one goes to something something dot zip. The second one goes to something 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 dot png. Like look at that, what is coming on hover, file cover, blah 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 blah. The end it's dot png. This is dot png. This is dot png. This is dot pst. Dot pst. Dot png. Dot pdf. Dot png. Dot pst. Dot pst. Killer. You can see after the file name there is something called pst or else png, right? So when you take a file name, after the file name, after the dot, you have the file extension. So for example, file extension. So for example, if you have something called as abc.pdf, abc is going to be the file name, pdf is going to be the file extension. And the main purpose of this extension is for you to be able to identify what type of file it is. Okay, identify the file type. And if you're asking me, why do you need to know the file type? What is the purpose of knowing the file type? Because when your computer know what the file type is, depending on the file, depending on what file it is only, your computer can decide what application to use to open the file. What app to use to open the file. Like for example, if you notice in my computer, wherever you saw this .pst, okay, wherever you saw the file manager again, wherever you saw the .pst file name, you can see it showing this PS icon, right? Photoshop based. The blue color icon is a Photoshop application. So all the .pst files, if I double click, it will open using the Photoshop application. And for all the .pdf, you can see a red color and white color icon, right? So all these PDFs that are there in my computer, it will open through my browser, Microsoft Edge. Then you can see what you call there are some file that goes to .csv or .xls. So .csv, all these files will open through my spreadsheet application, like Microsoft Excel. So depending on the file type, it will decide through which application should you open it. That's the main purpose of the file extension. Got it? The operating system identifies the file type using the file extension. Yes, it identifies the file type, but what is the purpose of file type? The purpose of knowing the file type is technically to know, okay, depending on the file type, it will decide what application to use, what do you call to open it. So if they ask you what is the importance of the file extension, the importance of the file extension is to know the file type. And why do you have to know the file type? In order to know which application to use to open it. Got it? They are used to identify the type of the file and let the computer know which application should be used to open the file. Yes, exactly. That's the answer. .jpg is a picture. So the answer for this question should be something like this. To know the file type, and decide which application should be used to open it. So if your answer had mentioned only that to know the file type, if you had just mentioned to know the file type, you get only 1 mark. If you had mentioned the part, what do you call, to know the file type and or if you had mentioned just only the part call, if you had mentioned just only the part call to decide which application to open should be used to open it. If you had mentioned only that, again 1 mark. If you had mentioned both to know the file type and decide which application to open, if you had mentioned both the points, then mark 2 marks for that, 1 mark each. To know the file type and decide which application should be used to open it. Okay. To know the file type and decide which application should be used to open it. If there's any questions, drop in the chat. Can we say help the operating system to identify the file type? So you're talking only about the file type, no? So you get only 1 mark. What is it? What's the doubt? Yes, what is your doubt? It's an imposter. Who is copying? Ignore it. Next. Explain, if you have doubt, drop in the chat. Huh? Explain the relationship between the user and the computer using the appropriate diagram. Okay. This is the screen, Hana. Right. So if you take the user and the computer, I'm going to take a separate page to show that. Let's take, or just use this place in the top. Right. When they ask you to tell about the, you use a diagram to show the relationship between the user and the computer, what they're mainly talking about is the user and the hardware. When they say computer here, they're mainly referring to is user and the hardware, right? So if the user wants to, what do you call, communicate with the hardware of the computer, how the normal method would be is the user might go and contact the application software. Okay. And from the application software, the message will be given to the system software. To be more precise, the operating system. And then the operating system will give the instruction to the hardware. Okay. So user can give instructions for the, what do you call, operating system. User can give instruction through the application software like this, or else without giving it through the application software, he can also give instructions directly. So if I take this as a user, this as operating application software, this is operating system, this is hardware. Without going like step by step, they can directly go from the user can directly contact the operating system as well. This picture is there in your tutor, I mean your textbook as well. Let me show you which picture they're referring to. Okay. Let me get your textbook, then you will recall this picture. If I take the grade 10, third lesson, fourth lesson. These are sequential access, random access, which we did in the previous question. The file accessing method, say step by step sequential, random because random access. But the other part of what you called what did I want to show? Oh, sorry, I want to show the other one. I think second lesson. In your second lesson, you have the relationship between what second lesson, fifth lesson only. The beginning of the fifth lesson was there. This. See? So user and what do you call hardware? Sorry, I missed one thing. I missed the other system software. So user can direct, this is the diagram which they're asking you to draw. So user and the computer, they can go like this from operating system to other system software to other system software. And through the other system software, they can contact the hardware. This is one way. Okay. Apart from going like this step by step, they can also go directly to the operating system. An operating system can directly give instructions for the hardware as well. Okay. So this is how the instructions flow from the user to the computer. In your diagram, you're supposed to draw each of these um, blocks and show the labelings. Your labeling should have both the labels. That is, the user can contact application software can contact operating systems can contact other system software, and other system software can contact hardware. This should be denoted. Additionally, denoting this is also important. If you have the exact diagram, put 2 marks. If you have an incomplete diagram, put 1 mark. Like in the diagram, if you had missed something, at least one thing, if you had missed some arrow is missed or certain part of it is missed, you get only 1 mark. But if your diagram is pixel perfect, exactly like this, put 2 marks. Anyone have any question here? Okay. Now tell me, out of 10 marks for this question, how many marks did you all get? If it shows the chat is disabled, just if it shows chat is disabled, click on my name or profile pic in this message and reply with your marks. What are the functions of operating system and utility software? Operating system has two main functions. One is to provide you an interface. Provide you an interface means allow you to interact with your hardware. So first thing is provide your interface. Second thing is manage the hardware. So providing an interface, managing hardware. These are the two main feature functions of operating system. In terms of utility software, it is basically to facilitate or to provide certain, you know, you can say it's a type of software that's used to provide certain core functions or important functions in your computer. Why doesn't it go upward too? Use your common sense and tell me, can it go upward? Can the hardware contact you directly? I mean, you can draw like this, both the directions, like this. I mean, because the data can flow from here to there, but only upwards you can't draw. You can draw like this. Like you can request for the data and you can get the response that you can mention. Yes. But directly means only up is wrong. Both up and down can. I miss other system software plus I didn't connect user. I missed other systems. Okay. I didn't connect the user and the operating system. Then 1 mark. In your cute arrows are going upward as well. You can do both sides, not only up. Excluding first and second question, I can do that. That's fine. Tudum, tudum, tudum. You use software to contact hardware. You use software to contact. Yes. Contact means communicate because your software is only going to give the instruction to the hardware. Which part, Umar? Hashmut? Now what's that? Good, 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 good. If there's any other questions, drop me a chat. I think today I did a presentation. Is it Ariba? Great, so yeah, we're gonna do that now. I think I answered all the questions. The flow chart again. Oh yeah, great. The flow chart again is technically, when you want to contact your device, when you want to give instruction for let's say you want to play what you called the Sri Lankan anthem through your left phone speaker. So for you to play the Sri Lankan anthem, like, is it possible for your speaker to connect to your mouth, and from your mouth can you play the song? No. So what you might do, first of all, you might go and open YouTube. YouTube is an example for application software. So once you go and open YouTube, in the YouTube, you might go and search for the song, and you might go and click on that song, Sri Lankan anthem. So once you go and click on that song on YouTube, what will happen behind the scene is the YouTube application will send that data, that these are sound, and it will send the data that these are the visuals that has to be played. So what your operating system will do is your operating system will take this sound, and behind the scene, it will go and give the speaker, it will instruct the speaker to play that sound. It will take the visuals, and it will go and give you a display and ask your display to show that visuals to you. So that's why you can see and you can, what you call, listen both at the same time. Okay, that's the task done by the operating system. Okay, so the operating system, certain times it can directly contact the hardware and ask the hardware to do it. But there are certain situations where it contacts a specific system software. Like for example, let's say in WhatsApp, you have the WhatsApp backup, right? So you can WhatsApp, you can back up your message. So as a user, you might go and click on the WhatsApp application, you might go and click on backup. So when you go and click on backup, that instruction will be sent for the operating system. Hey, he's asking to back up his message. Behind the scenes, when he's using some other applications, also back it up, killer. So there will be a system software called backup software, and behind the scenes, it will start backing up. I mean, WhatsApp is not a suitable example to take here because WhatsApp directly this doesn't happen, but certain applications that happens. So that's how it actually works. Got it? Perfect. Okay. As we have a couple of minutes, let's do this small question. Wait, let me see. Is this a worth it question? Is a useless question? You read this question. Okay, only that question is remaining in the paper. Let's go for a hard question. Let's have fun. I'll take this question. Where's my laptop stuck? It's a logic gate question. Ignore the scribblings done in this question. And I don't want you to do all the questions. That means I don't want the truth table. I just want you to figure out the question A and question B. Yes, just only these two questions. I'll give you 5 minutes for this question. As I know, there is no any mistakes here. Ignore the scribblings. Again, I'm telling you, ignore the scribblings. Um, as I know, there is no mistake, but there was a mistake. I can't remember. I can't remember exactly what was the mistake. But if you notice any mistakes, let me know in the chat. Just do this question. I'll give you 5 minutes. Let me on the time of 5 minutes. Okay, timer is on. Will have any questions? Drop in the chat. Others start doing this question. How to get this paper? This is actually a random question. Just mention this as what you call logic gate example question. I'll post a question if you want in the what you call community after class. Will you teach part C? Yeah, I will teach you, but not today. Yes, we don't have enough of time to do all three questions. Yeah. So, what's your finished, you can say. The humor. Okay, I put all of your hands down. Once you're done with this question, raise your hands up. Yeah, I will. Yes, I will not. Once you're done with answering this question, A and B, raise your hands up. If you have time, you can go for C as well. I don't think you will have enough of time for C, but because that's not a question that needs an answer. Right? Is it too much? What is turn is given, I'll explain about it. Let me answer this question. To do this question, I'll open Microsoft Whiteboard. It's easy. Quick, quick, quick. Someone. Why is it taking so long to open? One more minute. Why is one more not working? Because I need the question next to my writing, but you will not be able to sync it. That's why I'm trying to. Yeah. Okay. I'll just do on top of this. This is taking time. Yeah. I'll just do on top of this. So in this question, they have mentioned that a school science lab safety system is described as follows. The system is designed in such a way that if no teacher or no student is present in the lab, okay. So if there is no teacher or no student present in the lab, and if the gas value, so if the gas valve is open, okay, and if the gas valve is open, or and if either the gas valve is open or the chemical cabinet is open, a warning light will flash. Now, if you had read this paragraph properly, in this paragraph they have mentioned in which situation. Like first of all, they have mentioned they're talking about a school lab, and in this school lab there is actually a safety system. It seems so they are talking in which situation will this safety system actually operate. So they have said the safety system will operate when what do you call there is no teacher or no student. Dark color. No teacher, no teacher or student. Okay, when there is no teacher or student present, and okay, no teacher or student is present, and if either the gas valve is open or the chemical cabinet is open. So along with this, they have mentioned two other things as well. That is, first thing they have mentioned is the gas valve should be open, and along with the gas valve open, I mean apart from the gas valve open, or else the what do you call chemical cabinet has to be open. Chemical cabinet should be open. So always when you get a logic gate question, first of all, try to create a summary like this. Now, if you look at this summary, I have summarized, you can see it clearly. They have mentioned that for this, what do you call warning for the flashlight to warn? One thing is there has to be no teacher or students. Along with that, they have used the word called and, okay? And the either the gas valve or else chemical cabinet. Okay, either one of these two has to be open. So along with that, either one of this has to be open. Killer, they have mentioned. So I have just done a small sketch there, summarized. Huh? If I come down forward further, they have mentioned the system uses three senses. such as X, Y, and Z, where X is used to detect whether teacher or student is present. Okay, so X is going to be the sensor used to check if teacher or student is present. And sensor Y is used to detect whether gas valve is open. So purpose of Y is basically is a gas valve open. And sensor Z is used to detect whether chemical cabinet is open. So the purpose of Z is to check is a chemical cabinet open. Now, sensor X is input 1 if someone is present. And okay, sensor X gives you 1 when someone is present. Okay. Uh, Tell me, as per what the question had mentioned, what is our expectation from the sensor X for the alarm to be on? Here the question had mentioned for the alarm to be on, there has to be no teacher or student present, right? No teacher or no student. So based on that, tell me, what do you think is our expectation from the sensor X for if the alarm has to ring? Are we expecting the sensor X to give us 1 or are we expecting the sensor X to give us 0? In which situation do you think the alarm will ring? X is 1 means someone is present, right? So will the alarm ring when someone is present, which means X equals 1 will someone ring or X equals 0? 1 is present, 0 is absent. In which situation do you think the alarm will ring, 1 or 0? When someone is present, will it ring? Or when someone is absent, will it ring? 1 or 0? Again, see the question properly. I again have mentioned, here see properly. They have mentioned when no teacher or student is present. Is no teacher or student is present mean? What do they mean by that? The teacher and student has to be present or teacher and student has to be absent? What do you mean by it? I hope you're going for English class. Huh? So using an English knowledge, tell me when I say that no teacher or student has to be present. That means what? The teacher and student has to be present or absent? Exactly. When you say no teacher or student has to be present, the meaning of that is they have to be absent, right? So that means our expectation from that sensor X, right? Our expectation from the sensor X is actually 0. Is that part clear for all of you? Anyone have any questions there? We are expecting the sensor X to give us 0. Anyone have any questions or doubts there? If there are any questions or doubts, let me know, okay? So we are expecting the sensor X to give us 0. This is a compulsory, yeah? Along with this, sensor Y will give you 1 if the valve is open. Okay, sensor Y will give you 1 if the valve is open. Tell me, what is our expectation? Are we expecting the sensor Y for the alarm to ring or for the flashlight to be on? What do you think our expectation from this, what do you call gas valve sensor is? 1 means open. So tell me, should we want it to be open or we want it to be closed? The sensor Y, if it's 1, that means gas valve is open. If it's 0, that means gas valve is closed. As per the question, what was our expectation for the flashlight to be on? The gas valve has to be 1 or 0. Gas valve has to be open, right? In the topics we wrote, gas valve has to be open. That means what is our expectation of Y? 1 or 0. So the topics I wrote there, right? For the sensor to work, the gas valve has to be open. Here, for the flashlight, gas valve has to be open, right? So when we say gas valve has to be open, what is our expectation from Y? Y has to give us 1 or Y has to give us 0? Perfect. Our expectation for the sensor to be on, our expectation from the sensor Y is actually 1. We are expecting, what do you call the sensor Y to give us 1. Perfect. Okay, so I'm going to mention here, along with X giving us 0, we want Y to give us 1. Now they have mentioned the gas valve has to be open or else the chemical cabinet has to be open. Now again read this last paragraph and say, when I say sensor Z is referring to the chemical cabinet, and sensor Z is going to give us 1 when the chemical cabinet is open. So the sentence they have mentioned here, sensor Z gives an input of 1 when the cabinet is open, right? So what is our expectation from sensor Z? For the sensor to be on, okay, for the flashlight to be on, we want the chemical cabinet to be open, right? So when we say when we want the chemical cabinet to be open, what is our expectation from sensor Z? To give us 1 or 0? From sensor Z, what is our expectation? Yes, correct, 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 correct. Exactly. From the sensor Z, our expectation is actually 1. Because why? Z is equal to 1 means Z is open. The question has mentioned Z is equal to 1 means Z is open. And for the, see, the question has mentioned here, sensor Z gives an out input of 1 if the cabinet is open. See the last line in this part. Okay, in this part they have mentioned there, sensor Z will give you 1, will give you 1 if the cabinet is open, and opposite 0 means it's closed. And the first paragraph, it mentioned how the sensor works, right? The flashlight will be on when the chemical cabinet is open. So if we want the chemical cabinet to check if it's open, that means we want the Z to give us 1. Our expectation from Z is 1. Now, if you had read the question properly, they had mentioned there that along with the teacher or student not present means absent, okay? Along with the teacher or student being absent, they had mentioned a word here called either. Either the gas valve is open or else chemical cabinet is open. So that means either Y is equal to 1 or else Z is equal to 1. Okay. Either we want Y to be give us 1 or else we want Z to give us 1. First of all, tell me, are you all clear about this summary? Yes or no? This summary I wrote here. Are you all clear about that? If you have questions regarding that, drop in the chat. Okay. Now let's figure out the diagram. You can see in this diagram, okay, before you come for the diagram, I'll tell you one thing. If you make this summary properly, if you have this summary written properly, if you have to figure out, okay, what is it for the flashlight to be on? The flashlight is output, right? The final end product, the system we're going to make is a flashlight. So for this flashlight to work, once you have figured out for the flashlight to work, what should sensor X give, what should sensor Y should give, what each input has to give. If you have figured out this, then second step is it's very easy for you to figure out the Boolean expression. It's very easy to figure out the Boolean expression if you figure out this. The reason is because there is a small trick of how Boolean expression works. Okay. So if you're wondering what is Boolean expression is where you can show the whole diagram. You can show the whole circuit diagram using just only what you call characters, which means using only letters and numbers and symbols, right? Without any lines, without any shapes, okay? Without lines or without shapes, only using letters and numbers and symbols. If you want to show how a circuit looks like, that is what you call as a Boolean expression. At last, we have the undo in this. By mistake, I went and erased everything. Anyways, what do you call coming back to the point. So what do you call? Now I know what I need from X and Y and Z now. So there is an easy way how you can figure out the Boolean expression. There is something like this. If you want a specific letter, for example, let's take the letter A. If you want the letter A to give you 1, the meaning of that is in the Boolean expression, you take A as A. If you want the letter A to give you 0, that means you take the Boolean expression of A as A dash. Similarly, if you want, let's say in a circuit, you want B to be 1. For the circuit to work properly, let's say you want B to be 1, then you use B as this. For the circuit to work, if you want B to be 0, then you take B dash. Using this idea, if you create the circuit, if you try writing a Boolean expression, can you repeat it, please? Yes, I'll again repeat. Now, when you're making a circuit, we figure out certain things here, right? We figure out that for this flashlight to give us a warning, we want X to be 0 and we want Y to be 1, or We want Z to be 1, right? So after you figure out this, keep in mind that if you want something to be 1, you take the letter as it is. Y and Z, we want to be 1, so take the letter as it is. If you want something to be 0, take the opposite of that, X dash killer. Now using this, you can easily form the circuit, the Boolean expression. That is, you replace the and with the dot, replace the or with the plus, and you can say the Boolean expression is going to be X dash dot Y plus Z. Why I put Y plus Z in bracket is because they have mentioned X dash means we want the, what do you call, a teacher or student not to be present, and the word and is representing here, and either the gas valve is open or chemical is open. So Y is representing chemical, gas valve is open, Z is representing the chemical is open, and plus is representing the O. So this is how the Boolean expression is going to be. So using the paragraph itself, directly you can figure out the Boolean expression. Is that clear on floor? Brackets are compulsory? Yes, brackets are compulsory. Without the brackets, your answer is wrong. Is it okay if I use ABC instead of XYZ? Your answer is wrong. ABC is wrong. If you're using ABC, then you have to mention A is equal to sensor X, B is equal to sensor Y, Z is equal to sensor Z killer. You have to mention the labelings. If you have not mentioned the labelings, your answer is wrong. Brackets are compulsory, yeah. Because if I'm going to explain the reason why brackets are compulsory, I have to explain about bond mass. This is again going to take another half an hour. It's unmodded for this. So I lose marks. Yes, you get 0 marks because your whole expression is depending on who's marking your paper. If I'm marking your paper, I give 0 marks. I wrote as Q is equal to X dash dot Y plus Z. Correct. If you mention Q equals X dash dot Y plus Z, correct. But how do you know here Q is basically the output? Here they have not mentioned anything about the word Q. You'll get marks for that for mentioning, but okay, that's the answer for the question number B actually. And for question A, you can use this and directly find the answer. Now, if you want X to become X dash, obviously X has to go through which gate? There's two ways you can figure out the label A. One way you can figure out the label A is you want X to become X dash. So how to get X dash? X has to go through the NOT gate. That's one method. Another method is out of all the logic gates you have learned, there is only one gate, exactly only one gate that can take one input. See, only one input is coming, right? This is the input. So only NOT gate is the only gate you have which can take only one input. So if you see one input, definitely it's going to be NOT gate. It can't be any other gates. Only NOT gate can take one input. So definitely it's NOT gate. So A is going to be the NOT gate. Okay. Now, if I am marking, I said I will not give marks to the brackets. Now, second thing is regarding what you called B. Now, if you take Y and Z, we have sensor Y and sensor Z, right? Again, look at the diagram and see sensor Y and Z. We are saying Y plus Z, right? So plus is representing which gate? I always say if you write the Boolean, read the paragraph, take the Boolean expression first, then go for the diagram. Because from the Boolean expression, if you go for the diagram, there's less mistakes you will make. And now, actually, the first question. Why do you want to go for the third question? Step by step. Over. Exactly. Okay. So if you look at the question properly, the plus is used between Y and Z. So plus means OR gate. Even the question had mentioned OR, right? See, if you look at the wordings I wrote here, Y equals 1 or else Z equals 1. Here also I mentioned the gas valve is open, the top, or else the chemical cabinet is open. In the top I mentioned or else, the right side also I mentioned Y equals 1 or else Z is equal 1. So B is representing the OR gate. This B is representing the OR gate. And then if you take this X dash coming from here and Y plus Z coming from here, these two has to go through the which gate for the one layer to come? X dash and Y. What is the dot is representing the? Exactly. It's the AND gate. So C is representing the AND gate. So A is NOT gate, B is OR gate, C is the NOT gate. So up to here, put 1 marks for getting A is NOT gate, Put 1 mark for B is OR gate, 1 mark for C is AND gate, and 1 mark for the Boolean. I'll show. No, I don't. I got the Boolean expression from the paragraph. I will show you how to get the Boolean expression from the diagram as well. Wait, but before I go there, put 1 mark each and tell me out of 4 marks how much marks you got here. I will show you how to get the Boolean expression from the circuit as well. Wait, but before that, I'll be doing the third question as well. Even though I didn't ask you, I'll do it. I'll show you the answer as well. But before I go there, tell me out of 4 marks how much marks you got here. Good. Okay. So some of you all have this confusion about where to put brackets, where not to put brackets, and you'll mess up when you're going to draw the Boolean expression using the diagram. So using the diagram, when you're drawing the Boolean expression, this is how you should do it. Okay. Go step by step. In front of each gate, write the result. Like for example, if I go step by step, since X is going through the NOT gate. Once since X goes to NOT gate, X becomes X dash. So I wrote X dash here. Since a Y and since a Z, both of them are going to go to the OR gate. So how does OR gate's output be? You take all the inputs, and in between all the inputs, you have a plus symbol, right? So for this OR gate, from the top we're having Y, from the bottom we're having Z. So in OR gate, what happens is in between every input, we mention the plus symbol. So Y plus Z is the output for this OR gate. Okay. So Y plus Z is the output for the OR gate. X dash is the output for NOT gate. Now let's take the AND gate. If you look at the AND gate, first of all, always when you want to find the output, before you write the output, first of all, figure out what are the inputs coming. So for this AND gate, we have an input coming from the top. The input that's coming from the top is X dash. So write X dash. Then keep a space and write the next input. The input that's coming from the bottom is what? Y plus Z. So write Y plus Z. Now I'll tell you where to use brackets. If an input has more than one character, now A is one character, B is another character, C is another character. There are three different characters. Okay. So if an input has more than one character, then for that input, put a bracket. If you take the input that's coming from the top, it has only one character, just the letter X only. So no need brackets. If you look at the input that's coming from the bottom, it has two characters. Letter Y is there, letter Z is there. So if the input has multiple characters, you put a brackets for that. Okay, again, only if an input has multiple characters, you put a brackets. Once you figure out both the inputs, so the input that's coming from the top is X dash, input that's coming from the bottom is Y plus Z, whole thing in brackets. Once you've done that step, now you write the symbol. AND gate, we use the dot symbol to represent AND gate is used. So in between both the inputs, I mentioned the dot. So the output is going to be, or the Boolean expression is going to be X dash dot Y plus Z. This is how you figure out the Boolean expression by looking at a circuit. Okay, there are ways where you can remove the brackets as well. I'll tell that later. But for now, this is the base idea. Is that clear, all of you? Anyone having any questions here before I go for the Boolean expression and before I go for the truth table? I didn't ask I'll do the truth table, but I'll show you the truth table. But before I go for the truth table, let me erase all this stuff selected. Okay, I'll show the truth table. So if you look at the truth table, how you draw the truth table is step number one, write all the inputs. Well, coding. Quick. Okay. So to draw the truth table, first of all, figure out the inputs and output in the circuit. So in this whole circuit, we have three main inputs. One is sensor X, one is sensor Y, one is sensor Z. So you have one column for X, one column for Y, and one column for Z. So these three columns are representing the inputs we have in this circuit. After you figure out the inputs, now for every output, draw a column. So you draw the output from going from left to right. So if you see the first, in visual, you can see the first gate we have is A. And if you will notice earlier, I showed you, so the output of that A gate is X dash. So I have one column for X dash. Then if you take the second column, second gate we have is B gate. B I showed you earlier, it is OR gate. So output of the OR gate is going to be Y plus Z. So I write here Y plus Z. That the B gate's output is Y plus Z. Then the next gate we have is the C gate. The output of C gate was actually X dash dot Y plus Z. So every input has one column and every output has one column. This is how you figure out the columns in a truth table. For every input, one column, and for every output, one column. Anyone have any questions regarding column findings? If you have any questions regarding column findings, drop in the chat. Okay, next is the rows. Before you start filling this table, first of all, figure out, the easiest method is first of all, figure out how many rows will be there in this table. So if you take every row in this table, every row represents a scenario. A scenario means a situation. That means a possible combination. Now, for example, let's say there are two students in a class. Okay, if there are two students called Amal and Bimal, there could be one situation where both of them are absent. There could be one situation where only Bimal is present. There could be one situation where only Amal is present. Or there could be one situation where both are present. So these are all called situations. One situation where both are present, both are absent. One situation where both are present. One situation where only Bimal is present. Or one situation where only Amal is present. These are different possible situations, though. So you can figure out how many possible situations are there in a circuit or as a Boolean logic gate. Once you have the full circuit, you can figure out how many possible situations are there. Okay, the number of possible situations, number of possible situations. You can figure out the number using an equation called 2 to the power n, where n is representing the number of inputs you have in a circuit. Right, it's stuck. Okay, where n is representing quick. It's stuck. Okay, where n is representing the number of inputs this circuit can have. Now, if you look at the circuit we drew, again, I have labeled it in the table here as well. This circuit had how many inputs? How many inputs? How many input sensors? Or how many input switches? Normally, inputs would be a sensor or a switch. So how many inputs were there in this circuit diagram, which you saw here? How many inputs? We're getting data from how many devices? Or we're getting data from how many things? Exactly. X is one input, Y is another input, Z is another input. So we have three inputs. So you can figure out the number of possible situations using this equation. We replace n with the number of inputs. We have three inputs. Then you know 2 to the power 3 is equal to 8. So using three inputs, we can have 8 possible combinations. We can have 8 different combinations. So what you do is you draw the table with 8 rows, where each row is going to represent one combination. So I'm going to draw one row, two rows, three rows, 4, 5, 6, 7, and 8. So there are 8 rows in this table now. Now you start filling the table. Okay, so step number 1, figure out the columns. Step number 2, figure out the number of rows. Step number 3, fill in the inputs. So how you fill the inputs is, first of all, always start with the right side corner input. Now X is one input, Y is one input, Z is input, another input. We have three different inputs now. Start filling in the right side corner column. That's easy. So here, my right side corner column is going to be Z, right? And that's in the right side corner. So you fill this column in a pattern of 0, 1, 0, 1, 0, 1, 0, 1. So fill in that pattern. Then you go for the next input and double it. So here you're using 1, 0 and 1, 1. No? So here put two zeros, two ones. Two zeros, two ones. And then go for the next column and double it. So here double of 2 is 4. So 4 zeros, 4 ones. So if there was another column, double it. And if there was another column, 8 zeros, 8 ones. Like that. What you're going to do here is just for the right side corner column, go with 0, 1, 0, 1, 0, 1, 0, 1. Next column on was double, 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 double. And go in that pattern of filling until you reach the last row. And that's how you can figure out the inputs in the table. Up to here, is it clear, all of you? Anyone have any questions up to here? If there's any questions up to here, drop in the chat. Now we will start filling the outputs. This column is talking about x dash, which means we are taking the value of x. X dash represents the value of x going through the NOT gate. So when an input goes to the NOT gate, the result is going to be, it becomes opposite. So for example, if 1 goes to the NOT gate, 1 becomes 0. Okay. So if 0 goes, so here 0 is going through the NOT gate. If x is 0, x dash is 1. Basically the opposite. So if x is 0 here, x dash is 1. If x is 0 here, x dash is 1. So likewise, you write all the opposites of x. So here x is 1, here x is 0. Here it's 1, opposite of 1 is 0. Just keep on writing the opposite, 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 and fill that column because x dash is opposite of x. Next, we have y plus z. So y plus z means you're going to take the y column, you're taking the z column, and you're going to compare the y and z with the plus in between. Is it dark? Plus is representing the use of OR gate. Why is it start? Okay. The plus is representing the use of the OR gate. When high processing is happening, it happens like this. So how OR gate works is, NOT gate, you all know, NOT gate works in such that it gives the opposite of the input. How OR gate works is, it goes and checks if either one of the inputs are 1. Okay. So either one means, for this OR gate, we have y and z as input. You can see y plus z. So we're going to compare the y column and z column. If you take y and z as input, is either one of them having 1 as value? No. So you put 0. Here, if you go and check, is y and z, is either one of them having 1? Yes, z is having 1. So we write 1. So OR gate, what happens is you compare the inputs. Now here y plus z means y is one input, z is one input. These are two inputs for this OR gate. So you compare and see, is one of them having 1? If either one of them are having 1, just write 1. Either means one of them. Out of the two, one of them should have 1. Here, if you go and check, is either one of them having 1? No. So it's 0. Here, if you go and check, is either one of them having 1? Yes. Is either one of them having 1? Yes. Is either one of them having 1? Yes. So okay, you go and check, is either one of them having 1? If either one of them are having 1, you go and write 1. That's how you fill the OR gate column. Again, if you have any questions regarding this, stop in the chat. Now I go for my next column. In my next column, I have here x dash, which is representing this column, dot y plus z. Now I don't have to again go and check y and z separately because I already have a column here called y plus z. So what I can do is I can compare the y plus z column and x dash column using the dot operator in between. Dot represents what? Dot represents the AND gate. So I'm going to compare these two columns, the blue color highlighted columns there. I'm going to compare those two columns with the AND operator's logic. So how AND operator works is it goes and checks, are all the inputs 1? So only if all the inputs are 1, output is going to be 1. So if you go and check here, is both of the, now here we have for blue color, we have these two are the inputs, right? X dash and y plus z. Are all our inputs one? No. Here, x dash and y plus z is all our inputs one? Yes. X dash and y plus z is all our inputs one? Yes. X dash y plus z is all our inputs one? Yes. X dash y plus z is all our inputs one? Yes. X dash one input, y plus z one input. Are all of our inputs one? No. Here are all of our inputs one? No. Here is all our inputs one? No. And that's how you fill the final column as well. You compare x dash and y plus z. So once you do that, your table is complete. So this is how your final truth table is going to be. If you ask me for the truth table, are all of these columns compulsory? Actually speaking, all of these columns are not compulsory. The only compulsory columns are this last column and the final output column and all the input columns, which means these are the columns which are highlighted in green color. Is there, right? These are the columns that's compulsory. If you have the other columns, it's actually easy for you to find the answer, but not compulsory. Only the green color highlighted columns are actually compulsory. So how you will be getting marks is, if your this column is correct, these three columns are correct. Sorry. If you have, when x was 0, y was 0, z is 1. When x and y all three was 0, if the output was 0, then you get 1 mark, half marks. When x was 0, y was 0, z was 1. In this situation, if you wrote the output as 1, you get 0.5 marks. So for every row, you might get 0.5 marks each. So technically 0.5 into 8, around 4 marks, you can get maximum averagely in this table. If they're breaking the marks, that's how they might break. Depends. Fifth row should be 0, right? 1, 2, 3, 4, 5. Sorry, my bad. Yes, fifth row should be 0. Thank you. Yeah, my mistake. Okay. Any other questions, anyone? That was my mistake, actually. So this is how you do logic gate questions. Simple. So questions are normally easy. Just had to have formula. Anyways, anyone having any doubts here? So with that, we're done for the day. And sorry for dragging around half an hour more. But yeah, if you have any questions, I can stay and ask. Others, I can leave. We're done for the day. Walaikum salam. Unit 4, you mean logic gates or the grade 11 unit 4? You're too slow and ending part. Not exactly. I purposely reduce. I mean, these are things which are easy in general. So if something that is easy is not understandable by everyone, that means I have to go slow. If say something that is hard and you all can understand, I can go in average speed because everyone of you all can understand. So if I go in average speed, you all can understand. But if there's something easy and still you can understand, then you go slowly. That's the art. Know your audience. Even if you have, there's nothing but big you're going to get it from it. It's just questions technically. There's no theoretical parts in the. That's fine. So I'll be doing a second term test paper discussion. No? When I do that paper, you will know how many questions are asked from the professor. Something big. On 30th, inshallah, I'll be doing a paper seminar on second term test. I'll inform them through the WhatsApp channel. Why, Umar, why? Okay, so as there's no other questions, I'm going to end the meeting. But again, if there's anything, you can WhatsApp and get things sorted. I have the IC second attempt is tomorrow. Okay, if you have the exam before 30th, then for now, what you can do is if you go to YouTube and if you go and search for Master IT, let me show it to you. You go and search mastery, you'll get this yellow color channel. You go and click on this yellow color channel. You can see in the bottom there's something called term test seminars. So there you might have here the second term test target seminar. I think all three are second term tests. There should be in third term and first term as well, but I have playlist in second term. Grade 10, one is grade 11. I think two are grade 11s and one is grade 10. So there is a difference between the two, I guess. I can't remember exactly, but you can just go through this for now if you have your exam before the 30th. Because on 30th, I'll be doing so. Okay, so as there's no other questions, I'm going to wind up. If there's anything, you can WhatsApp me and get things sorted. So WhatsApp to this number, okay? I'll talk in the chat 072-217-8167. Okay, have a nice day. Bye bye. Good night.